In 1938, a team of German scientists, led by chemist Otto Hahn, decided to repeat Fermi's work. Only they quickly found that his claim to have created a new element was wrong. They identified one of his elements as barium, which has 56 protons in its nucleus, compared with the uranium he'd started with, which has 92. Hahn was intrigued. It's as though uranium had been split in two. Hahn wrote of his confusion to a colleague, Lisa Meitner, who was working in Sweden at the time. As an Austrian Jew, Meitner had recently fled Nazi Germany and was spending Christmas 1938 at the seaside with her nephew, Otto Frisch. Meitner puzzled over the mystery, and together with Frisch, she considered the uranium nucleus. Because it's a relative giant, it must be quite unstable. She suddenly realized that the uranium nucleus had split in two. Both Fermi and Hahn had witnessed what we now know as nuclear fission. But then Meitner worked through the calculations. She reckoned that the combined mass of the two fragments was slightly less than the mass of the original uranium nucleus, by about a fifth of one proton. She wondered what had happened to this missing mass. Then it slowly dawned on her. Einstein's famous equation, E equals mc squared. The missing mass had been converted into pure energy. Meitner's flash of insight heralded the creation of the nuclear age, where exciting possibilities for a new form of energy will be countered by its potential for weaponry. This site at Orford Ness used to be a military testing ground, one of the most secret places in Britain. Back in 1939, Lisa Meitner's work on nuclear fission was published as war cast a long shadow across Europe. It shook not just the scientific community. Governments who stood on the brink of conflict became aware of the extraordinary power that could now be wrought from an element. On both sides of the Atlantic, scientists were scrambled to investigate the potential of this new discovery. The result was the US-led Manhattan Project. Its aim was to produce the first atomic bomb. Using scientists from America, Canada, and Europe, the $2 billion project's rapid progress was fueled by fears that Nazi Germany was investigating nuclear weapons of its own. Both the Germans and the Allies knew that the uranium nucleus could be split by bombarding it with neutrons to release a huge amount of energy. But to be effective, that energy needed to be released almost instantly. A slow reaction would produce a uranium fire, but no bomb. So both sides poured their efforts into perfecting the key to rapid energy release on a grand scale. A chain reaction. Imagine this ping-pong ball is a neutron, flying towards an unstable uranium nucleus, a mousetrap. It sets off the mousetrap, which in turn forces a new neutron into the air. Now, in a chain reaction, this is what would happen. One neutron to set it off, but loads of mousetraps of uranium primed and ready. Now imagine each mousetrap of uranium releases a blast of energy, that same energy that Lisa Meitner had calculated. The resulting blast would be enormous. In 1942, Italian physicist Enrico Fermi, now living in America, became the first man to unleash uranium's chain reaction. Uranium. It harbors the power not only to win wars, but to electrify millions of homes. Before its radioactive secrets were revealed, this element's glow under ultraviolet light made uranium glass a desirable asset. About 7 weeks' worth of your year's electricity comes from nuclear fission, part fueled by uranium. And it's used in tank shells, as its great weight allows it to drive through armor. But processing uranium for bombs was both difficult and costly. America would need to come up with a suitable alternative to create its nuclear arsenal. Chemists were once limited to using the elements nature provided. Now, science breached this frontier, creating synthetic elements. And with this new power would come new dilemmas. In 1941, the next element to be forged by mankind would become infamous. It was called plutonium. Scientists quickly realized that plutonium was capable of undergoing nuclear fission in a way that could fuel an explosive chain reaction, and it was soon being made into a bomb. The discovery of nuclear fission to the creation of the first atom bombs took less than 7 years. And on August the 6th, 1945, the full accuracy of Lisa Meitner's scribbled calculations was revealed. 1900 feet over the Japanese city of Hiroshima, one piece of uranium-235 was fired into another, causing a rapid chain reaction. Just over half a gram of mass was converted into energy. That's 1/10 of a 10p coin. But it exploded with a force equal to about 13,000 tons of TNT. Three days later, Nagasaki was hit by a plutonium bomb, bringing the death toll from the two bombs to an estimated 200,000. Plutonium. It was named after the planet Pluto and also shares its name with the Roman god of the underworld. Bombarding uranium-238 with neutrons creates this powerful element. A gram of plutonium has the same energy as a ton of oil. Many of the Cold War's nuclear bombs contain plutonium. The first man-made objects destined to leave our solar system, the two Voyager space probes, are powered by plutonium. The dream of turning lead into gold is what drove the early alchemists. And the dark race to create the atom bomb was a kind of modern alchemy,